I'll introduce my project for the pattern recognition class. This project is aimed at using the memory neural network modules to solve the problems from the BA tasks, which are a set of QA tasks provided by Facebook AI research team. Since this is one kind of natural language processing problems based on contextual information, deep learning methods like neural networks are the favorite choices. Since there are many different neural networks to settle this kind of problems, I refer lots of papers to decide which networks should be used in this project. After all, I decided to use the end-to-end memory networks, extension networks based on memory networks, to help me design my module. In this report, I would make a brief introduction to the memory networks models. I use Keras framework, a model-level framework using TensorFlow as back-end engine to implement this project. After training and testing my model using the BA tasks, I compare my results with other results gained by other neural networks. Now, first I will make some introductions to the BA task and the basic memory neural networks. The BA tasks are the synthetic tasks which can be used as test case for many NLP learning systems. The synthetic data set is classified into different skill sets, which makes it easier for developers of NLP learning systems identify the failing of their systems. There are 20 different kinds of cases in the BA tasks. Follow some typical example of each kind of task in the BA tasks. The question 1 is the question about a single supporting fact. To answer these questions, the learning system need to have the ability to find the single supporting fact to answer the questions. Take an example. For the question, John, you are given the story John is in the playground and Bobby is in the office, and the question is where's John? So you can find the single supporting fact of the John is the sentence that John is in the playground. So the answer will be playground. The question 2 is the two supporting facts question. In this question, you will be given the background story, and to answer the questions, you need to find the learning system need to find the two supporting statements, which are trained to answer the question. For example, to this question, to this story, John is in the playground, Bob in the office. John picked up the football. Bob went to the kitchen. So you can see the question is where's football. So you can see John is chained with the playground and John is chained with the football. So the question is where the football. So you can find the supporting facts through the chain between John and football, John and playground to find the answer playground. The question 5 is the question of three-argument relations. In these questions, the learning system need to have the ability to recognize the three-argument relationships. In this example, the story is Mary gave the cake to Fred, Fred gave the cake to Bill, Jeff will get the milk by Bill, who can give the cake to Fred. So you can find the relations between these three persons and three people and their relations between the cake. So you can give the answer Mary. The question 15 is the question about the basic deduction. That means the learning system need to have the ability to give the basic deductions when based on the context information to answer the questions. To generate the BA task, you can use the BA task project on the GitHub, and the dataset can be generated by this project, or directly you can use the original tasks generated by the Facebook Research AI team. And through the generated projects, you can customize the parameters for each task. Take an example: if you want to generate the text in the type of the path-finding question, you can specify the path length and decoys through the command like the showed on the slides. Now, introduce some basic concepts in the memory neural networks. The first I want to introduce is the concept of the perceptron. The perceptron is the supervised learning algorithm of the binary classifiers. It can be understood as the artificial neurons for the computer system. Take examples. When a perceptron takes x1, x2, x3 as input and produce a binary output, the perceptron's output is decided by whether the weighted sum of the input value is less than or greater than a certain threshold value. And the basic neural network consists of lots of the different kinds of perception, shown as the picture in the slides. The leftmost layer is the input layer, which takes the input from the user, and the rightmost layer, the output layer, which output the corresponding answers to the user. And the layers between the input layer and the output layer is called hidden layers, which can where the procedure of training and testing are mainly focused on these types of layers. And it will more be detailed described at the next slides. The next basic idea is the softmax regression. Unlike the naive perceptron mentioned in the former slides, which can only produce a binary output, softmax regression is a model which can produce a possibility output, which is useful when the learning system needs possibilities to produce some responses. In softmax regression, the evidence from each input should be summed up and then be converted into the possibilities. And the detailed algorithm is shown on the slides. The evidence is the sum of the weighted value of inputs plus the threshold value, and the softmax value of some input x is the normalized exception value for x. Yeah. The entire process can be clearly described by the figures shown on the slides. There are three input x1, x2, x3, and three output y1, y2, y3. And there are three threshold value b1, b2, b3. To decide each value of each output value, you need to consider this and you need to put the weighted sum of the weighted input values plus the threshold value and convert the values through the softmax algorithm to output the corresponding y value. In this part, I will introduce my projection implementation. I will introduce the architecture of this project and each layers. My module is based on the end-to-end memory networks, which will be abbreviated. This module is extension memory networks provided by Jason Westons. The difference between these two modules will be mentioned in the following in the later. In these sections, I will introduce network architectures, then describe the detailed implementation for each layers one by one. Besides the model library framework, Keras is chosen as my main tool to build my memory network. This memory network consists of memory extension memories and four main components. The input feature map components, generalization components, and output feature map components, and the response components. The input of the memory network is the story. Each story symbols, which contains the story and the query question and the corresponding answer. And after being processed layer by layers, and the memory network will update the model parameters based on the training dataset, and in the last stage, it will give response feature factors as output. In the input feature map component, the input will be converted into the input features. And in the generalization component, the memory M will be updated based on the new input features. The updated memory will be used in the future stage to generate output feature map. And in the output feature map components, the output feature will be produced given current memory state and the new input. The output in response component, the output feature will be converted into the response format desired, such as textual response or the index representing the texture information. First, in the pre-processing stage of the input storage, my project will divide the whole input storage into three different objects into the input storage, query question, and answer objects, three objects, and they are converted into the index format based on the word dictionaries built in my project. Which is word dictionary? Take example. In this project, the index of the word John equals 15, and the index of the word is equals 1, and the index of the handsome is 33. So John is handsome. This sentence can be converted into tuple representations like 15, 1, 33, which is easier for the future usage process. Easier for the future to be used. In the input feature map stage, as mentioned above, the input X can be divided into have been divided into the three components: the story, the query, question, and the answer, the three objects, and they are now in the index representations. But their current representation doesn't contain any future information that can be trained on. A word embedding method is used to solve this problem. What is word embedding? Take example. To word embedding is to make a word converted into a parameterized function mapping words in some language to high-dimensional vectors. Take example is to vectorize the let's vectorize the word cat, and the output value of the cat can be a tuple like tuple value like 0.2 minus 0.4 and so on. The high-dimensional vectors will be assigned some features to the words, which we can use to train in the future stage. In this project, it is implemented by an embedding layer to the networks, the code snap. Oh, no code snap, sorry. And in the generalization component, I choose the simplest generalization function, that is just get the next amp index to store the new import feature representations as the new memory for that index. Of course, the memory is stored in the vector representation format. If the memory buffer has been full, then the memory network will forget the least important memory to free space for new memory. In the output feature map, there's a mainly difference. There is mainly difference between the memory network and end-to-end memory network in this stage, because in memory networks, the output feature representations are found by a certain choosing max algorithm, which is not continuous enough to train via backpropagation and the required supervisions at each layer of the input-output pairs. So to solve these problems, the end-to-end memory network is using another algorithm. This model provides a more continuous form of input-output pairs, which makes it possible to be trained through the end-to-end. In this model, searching more supported memory is replaced by building match possibilities between query feature and each memory. The possibilities are calculated based on softmax algorithms shown in the slides. Because this function now is more smooth than the original one, the learning simply can compute the gradients and backpropagate through it. It is implemented by adding a merge and activation layers to the memory network. Of course, the output is in the format of the vector representation too. In the response components, it will generate the answer for the query in the vectorized format. The sum of the output vectors and the output query are passed and weighted to generate the internal state value, and then be assigned softmax algorithm to generate the final response. The output of the from the response components is in the vector representation, which can be converted into index representation later and compared with the correct answer to make our learning systems more accurate. After building this project, I tested the 20 types of tasks from the BABI test and gained the accuracy of each type of tasks. So I found some interesting things from the testing. Compared with the basic neural network, the end-to-end memory network provides more accurate training results. The most difficult, and the second point is the most difficult part of the for computer understanding natural network language is the reasoning part and the past finding part. You can see the accuracy for these two part of tasks are very is lower than the other types of questions. I think the problem is the computer is still hard. It still feel hard to build the relationship, natural relation situation from the context information. So it's very hard for the computer to real learning what the situation in the real world is. So it feels difficult to answer this kind of questions. My presentation over, so now I will show the demo code in my project. This is the code for my project, and you can see there are 20 challenges, 20 type of challenges in my project. And if you want to test one type of them, you can need to change the parameter in my source code. If you want to type the questions of the counting type of the counting question, you need to change the challenge type to the counting type, and then run my code. Set. You can see the project is using the tensor as with the tensor. Yeah, using the TensorFlow as a backend engine, and here is some basic information of the input story, like the simple number and max length, and the input shape, and the queries. You can see 3 different objects from one story input. Then here is the evaluation time, and this is the accuracy data. You can see after the first epoch, the accuracy is 0.5680. It will be the accuracy will increase after each epoch has been trained. You can see the accuracy increased after another epoch of training. It will take a long time to finish the process of training all the tasks, so we don't have time to see the results. I can show you some results I've gained from the tasks. I output the results to the text file, then I can analyze the results of each task more easily. Yeah, you can see after 120 epoch, I will get the result accuracy and the results evaluation. So my presentation is over. Thank you for watching.